So shall we start?
Yeah, sure.
Okay. So first of all, could you please can you tell me about your recent projects? Like we have been working recently, just in the past 1 year, or like how many projects you have delivered or engaged within that period of time, and what was your role on those projects, and what features you have developed in that?
Okay. So my last project was like an auction website. What we did was we worked on um, like like SSE event based like a architecture where we places like where a user can come and place a bid on a tractor or any kind of equipment. So as soon as they place a bid, the real-time event will be generated from backend and it will be received on front end on different environments as well. Also, we have used authentication, stateful authentication using Redis. So in case something goes wrong, or like in case like a user does like uh, sort of like unethical activity, we can block them from our end by removing their session and deactivating their account. So we achieved that using JWT session as well as saving those sessions in Redis. We using AES, we encrypted those tokens so that user cannot anyone like if you have that JWT token, you can just go to jwt.io and get the details out of that token. We did put some of the device details like device ID, or so that we can detect which device they are logged in from, what are the metadata of that device. So we put that metadata in the JWT token. That's why we had to encrypt that token as well. So we did that. Also, along with that, we used RabbitMQ for inter microservice communication. So we had like a feature. If we develop a feature, it has the own microservice. We had this like microservice for a particular like front end. We had that kind of architecture, not a gateway architecture where all the requests comes from one end and it is distributed to different microservices. In this project, we used MongoDB as backend. So all of the collections were generated through Mongoose, and we utilized that. Like all of them had indexed as well. All of them were indexed, but on basis of like the things that were frequently utilized. So we had that as well as managed. Uh, we did not require sharding because the user base was relatively less, and uh, and the the data was actually divided. Basically, for frequent searches, we integrated Mongo search, and before that, we used to use Algolia. So Algolia is a like fast cache tool where we can you can just search for any sort of data, and it will get you the records, frequently visited records. So we utilize that for better searching, as well as we use SendGrid for email service. So we used SMTP, and SMTP for third party service. We utilize SendGrid. This
Okay,
was like
and what was the user currency of that project?
uh, user base was 15,000 concurrent users we handled.
And what was the daily active users in that?
Daily active users, like it was the amount that I'm telling you right now is 15,000 daily user activists. We got that from Cloudflare. Real time data we got that from every day from Cloudflare. Active users, total active users throughout the time were like 50,000. So
Okay.
we and the one problem that we faced was there was like we did not perform the spike test during that time because it was in very initial phases. but client did not actually expect this much amount of traffic at all at once. So our model was all the auctions will be performed on Tuesdays. It was named as Tractor Tuesday. So what happened was like it spiked like way too much, and our backend actually froze during that time. So what we did was we prepared a Terraform script, and in that script, if something happens where CPU usage goes above 70%, we automatically deploy a new EC2 instance, and in that EC2 instance, we use like T3 X large machine, which has like 4 cores and 16 GB RAM. So there was one issue with Node.js. What we observed was it was not occupying all cores. It was running on one core, and it was consuming other cores using libuv or like other libraries, C++ libraries we had. So the data, the request, the connection that we were making, we had to separate it out. Like we had to create multiple instances of that server using PM2. So we did that, and we updated our script, and then it was working fine because now more connections were acceptable, and we had like lots and lots of concurrent connections because of SSE events. So that was also one thing that I faced. So what we did was we prepared another microservice for just for SSE events, because constant connection was being made for SSE events, and they were frequently making them. The users were making them, but only thing which was used in SSE events was just delivering the objects. So we just made we just made it a new microservice, attached it to a queue base, something like RabbitMQ, and then we were sending the objects to that.
Okay, and how did you optimize the MongoDB connection, like to prevent opening a new database connection in every request?
So we use pool. So once the pool is being made, now new connection, whenever the new connection is being made, it just takes the data from it. It just connects to that pool, and they take the data from there, and it close the connection afterwards. So
Okay.
also one thing we faced was in the initial phase, we faced like we had like a trial version of MongoDB, which has like shared pool, like shared cluster. I'm sorry, like shared cluster. So we had to take a dedicated cluster from MongoDB, so that like they also had like multiple concurrency issues with shared clusters. So we resolved that using like paid version of that. We should have done that earlier, but like the project was in very initial phases, and we didn't expect that much of users all at once.
Okay, so did you create a separate pool for each service or like a shared global pool?
For each microservice, we had a shared pool, like not for like all of them are connecting with one pool. They all one instance has like a shared pool, and then in that connection, for example, if you're receiving uh, let's suppose we created nest.js, we created it on nest.js, not node.js, nest.js, and like nest.js is super framework of node.js, express only. So uh, basically we initiated that, and we just created a pool of 100 connections, and each of the instances had those 100 connections. We know like that is expensive thing, but like the connections that were made was actually pretty hefty. So we had to like optimize that as well later on.
Okay, so you were using the shared pool, so like for each service, right?
Yes.
So
Each-
but what happens like if any case your database will get halt or get overwhelmed, then of course it will affect on every microservice. So then how did you resolve, or how will you have you faced this issue?
that is the issue. Like we did not it was in a very initial phase. It is still in under development. It is very initial in very initial phase, and we halted our auctions for the time being so that we can test our new architecture and like perform. Currently what we were thinking was we were also like just for this sake we have like a backup ongoing backup that goes on inside the MongoDB, which is like irrelevant right now, but like we had that as well. For that we were thinking sharding and distributing all the data as per the like microservices. So if one of the microservices is consuming some sort of data, it should not be consumed by other sharded
So currently you are facing this issue. Currently it's not resolved yet, right?
it's not resolved yet. Yes, we were still working on it.
Okay,
Also,
okay.
the other thing that we were working on it is poison pill issue. Basically, we have to made a new queue so that like all the requests which were not which are in pending state, maybe because of, for example, I told you like we had this issue, right? The 70 CPU usage goes above 70%. So during that time, when Terraform is creating a new like instance for us, and it needs to consume those events. During that time, all of the rejected events will go to poison pill queue, and then over there we will just basically basically we will retry that same event and then process it in another instance.
Okay, so like, do you think like by creating the separate pool for each microservice can resolve your solution, resolve your problem?
Mm, I don't think so, because at the end of the day we will still occupy the same cluster, and the cluster will have limited amount of uh, connections available to it, right? So for that, deploying a like different clusters which will have their own connections, available connections, that can resolve our issue. I'm not sure about this answer, but that's I would go for, and I will look for that.
Mm-hmm. Okay, 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 okay.